All right, so good morning, guys. We're at lesson 1.8. Quadratic transformations is what we're calling it. And so we're going to be looking at and reviewing the vertex form of these quadratic equations. Yesterday, we looked at the standard form of the quadratic equation, and we also graphed the quadratic equation using Desmos and standard form. And we were able to see like some important information based off of that equation. Once we graph it in Desmos, we could identify the vertex, we could identify the x-intercepts, the y-intercepts, and also the axis of symmetry just from looking at the graph of the quadratic equation in standard form. All right, so today we're going to focus or put that focus on, well, the vertex form and try to see some information that we can derive from the vertex form. So our learning objective today is that students will understand vertex form, identify the vertex, the axis of symmetry, and characteristics of movement. And movement is just what we call in mathematics some type of transformation. Okay, so let's move on. All right, now from yesterday, let's see what you remember. All right, so given this graph here, you'll see that we have some key points here. You'll see we have some x-intercepts, the y-intercept there, and also the vertex. So what I want you guys to do is to see if you can identify each one of those values. Okay, I'll give you a few seconds just to take a look at that. All right, so very briefly, so if you'll notice that the x-intercepts are the points where it crosses the x-axis. So in this case, we have two x-intercepts, which one is at 2.268, and the other x-intercept is at 5.732. Okay, those are x-intercepts. The y-intercept, it crosses the y-axis. I'll get a different color. Crosses the y-axis here, okay, because that's our y-intercept at that point. So it crosses the y-axis at 13, okay? Now, our axis of symmetry is the line that goes through the vertex, all right, and it's this point. And so since I know what the vertex point is, which is 4, 3, I know that the axis of symmetry is going to be the x-coordinate of that vertex. And so when I write the axis of symmetry, this is an equation of a vertical line. Okay, this is an equation of a vertical line. So that means that it has to be x equals something. Okay, so since it has to be x equals something, because we have to express that entire line, it has to be x equals 4, because that 4 is the x coordinate of our vertex. And quite naturally, you guys can automatically see that this is your vertex point down below. And so that vertex point is expressed as coordinates. So it is 4 and -3. So that's where the vertex is located. Okay, so yesterday we discussed uh, one form yesterday, and that was standard form. And we understand that standard form can be rewritten in the form of y equals ax squared plus bx plus c, where a, b, and c represent, and let me highlight that for you, a, b, and c represent real numbers, okay? And we know that a can never be 0, because if it became 0, then it would make the equation not a quadratic equation. All right, today we're going to be looking at quadratic equations that are expressed in vertex form, okay? Vertex form. And above there you have y equals a times, open parentheses, x minus h, close parentheses, and then the whole thing is squared plus our k value. All right, so we know that we're a, H and K are real numbers, and again, A cannot be 0. And if A is 0, this is what would happen. Okay, let's take a look here. So we notice that even an equation or a quadratic equation written in vertex form, the A still cannot be 0 because the square term, which makes it quadratic, would disappear. Okay, meaning that it's no longer quadratic. So if I were to graph this equation now after substituting 0 in for A, it wouldn't create a quadratic equation, but you'll notice where it would probably create a linear equation. Okay, all right. So now if we take a look at the uh, vertex form of the quadratic equation, we'll notice that we have different highlighted values. So there is going to be some number that is going to be in the place of A. There's going to be some number in the place of H. There's going to be some number in the place of K. The other values we don't have to worry about when we're trying to express an equation written in vertex form. So here below, you'll see or you'll notice we have just an equation where we have those values that are already filled in. So you'll notice that the A value is on the outside. Okay, so in this particular case, our A value would be -2. All right, and in this case, our H value would be +6. Now, some of you guys may say, well, it's a negative clearly in front of that, and that is true, but wait until you see why it is +6. Okay, and then over here, our K value is also a +5. All right, so now looking at this expression here that we just looked at, we know that -2 is in the A position, 6 is in the H position, and 5 is in the K position. So what we want to do, we want to graph that function. And when we graph that function, this is what we come up with. Okay, well, you should get this graph if you go to Desmos and graph this function. And what you'll notice is this. You'll notice how this 6 is showing up in our vertex. And you'll also notice how this 5 is also part of our vertex. Wow, that's very interesting. All right, and that's because the H value, in this case, the H value and our K value both represent our vertex. So over here, if we know H and K, then we know the vertex. All right, keep that in mind. If I know what H and K is inside our equation, then I know what my vertex is. Okay, if the equation is written in vertex form. Okay, so vertex is made up of the H value and the K value, as we already talked about the position of them inside the equation. So let's take a look at some examples. So if I'm looking at the example -2, this first example here, all right, and I want to identify my vertex. I can do that because I have a value that is in my H position and I have a value that's in my K position. So I know here automatically without even graphing this that my vertex is going to be a +3 and a +5. All right, let's look at another example. Here we have this example. I know I see where my H is and I see where my K is. So I automatically know that my vertex is going to be a +2 and a -4. All right. Now let's look at another example here. I know I see where my H and K values are. So I know that my vertex is going to be here, um, a -3 and a -2. All right. And see here that my vertex is going to be a +7 and a +8. That should also be a +8. Okay, that should be a positive 8, not a negative 8. Okay, so with that being said, let's think about this. Well, if I look inside where my H values are, and I'm going to highlight that for you so you can see. So all of your H values are basically the values that are inside the parentheses. Okay, and if you'll notice these H values, the sign is basically the opposite. So you see how this is -3? This made my H value for my actual vertex a +3. This is -2 technically. This made my H value a +2. This is +3. This made my H value a -3. And this is -7. This made my H value a +7. So you can kind of almost see that trying to get the vertex from the equation, you're kind of going to do the opposite if you're looking at your H value of your vertex, okay, given the equation. Now, on the other hand, when we're looking at the K value, well, the K value is just whatever it is. So this is +5, this is +5. This is -4, this is -4. This is -2, this is -2. This is +8, this has to be +8, and this would be for my any of my K values. Okay? So I know now that just looking at the equation written in vertex form, I can determine what my vertex is. And I also can determine what my axis of symmetry is if I take it a step further, right? So over here, I'll know automatically that my axis of symmetry, this is without even graphing it, my axis of symmetry is x is equal to 3. My axis of symmetry is x is equal to 2. My axis of symmetry is x is equal to -3. And my axis of symmetry is x is equal to 7. Okay? All right. So just some really good information that you guys can get just from being able to determine the vertex just from an equation. And it all comes from the vertex form. Okay, so now we're going to compare some of these values when it comes to graphing these quadratic equations and Desmos that are written in vertex form. We kind of know what the H and K does to the quadratic equation, but now we want to look for like some movement. Like how do they affect the graph? Okay, how do they affect the graph if I were to graph this in Desmos or in my graphing calculator? So right now, as you can see, I have a graph in vertex form plotted in Desmos, and we want to look at the effect of A, H, and K on this graph, okay? And then we're going to make some note of it. All right, so first, let's start with the K value, okay? Or the H value. We'll start with the H value. So now, as you can see, right now my H value, and when I say H value, I mean here, okay? My H value is at 0. So this is saying that if I come over here and I plug 0 into this value, is 0 kind of like this is what the graph does. But we want to find out, well, what happens when the graph changes, okay? When the graph changes and it goes from 0 or its other values. So I'm going to play here because I want us to just observe. All right, so now we're looking and seeing how these values change. As you note and see that these values, as they get larger and larger and larger, this thing is either going to move left or right, okay? Or as they get larger, the parabola moves to the right, and as these numbers go smaller, meaning they become more and more and more negative, very, very, very small, they go to the left. So over here, just the observation that we can make, I'm going to draw a little picture. All right. And so I see that, and it's not the A value. Sorry about that. It is the H value that we were looking at. All right. So as values get bigger, I see, or as my H value get bigger, this is going to either move to the right, okay, as we just saw. And as my H values get smaller, it's going to cause the parabola to shift left, okay? All right, so very good. All right, so now let's look at only the effect of K. All right, so K is here. K is right here. And so right now K is at 0. All right, but what happens when K is not 0? So right now K is 0. But what happens to the graph when K is 0? Well, let's kind of preview that and see what happens. All right, so, oh, what do you notice? That's right. As K is changing, you see the graph is shifting up and down. It's no longer just moving left or right. It's now just going either up or down, up or down. All right, so I'm going to stop that here. And actually, I'll keep that playing while we're doing this. So when our K value changes, it's going to cause the graph to go up, or it's going to cause the graph to go down. All right, so as my K values get larger, the graph is going to shift up as we've experienced. And as my K values get smaller, it's going to cause the graph to shift down. Okay, all right, so I'm going to stop that right here. And now, lastly, we're going to take a look at the effect of the A value, all right, which the A value is right here. And notice how the A value is not 0. They didn't start the A value at 0. So remember, because if A was 0 here, then this wouldn't be a quadratic function, all right? So anyways, A right now is 1, okay? They started A at 1. But now let's take a look at some effects that happens to A. Now, this is A. Observe the values, okay? Observe the values. So I'm going to hit play here, and let's just observe. All right. Look at that. All right. So what do you see is happening here? First, we see it looks like the graph is flipping up, and then it looks like it's flipping down. But if we pay close attention and we kind of slow it down, the graph kind of, let me stop here. Okay, so I'm going to kind of manually control it myself. So we're going to start back at 1, all right, or negative 1. And as the graph, the numbers get larger, look at this. The graph looks like it's trying to come together, doesn't it? Look how close it's coming together. It looks very skinny, doesn't it? Look at that. So look at the numbers grow and look how skinny the graph looks. But then when I take it back the other way, oh, let's look at 0. Look at what happens at 0. It's not even a quadratic function anymore. It looks like more like a linear line, right? Wow. Okay. So now, look, I'm going negative. My numbers are getting larger negatively. But look, it's like the graph is flipped down now, but it's growing like skinnier together, flipped down. All right, so I'm going to leave that playing. And let's go over here and kind of draw a conclusion. So first of all, we saw that the A value causes the graph to get either narrow, wider, okay, or narrow. All right, and I'm going to draw a picture. So when that graph is wide like that, or it causes it to be like real narrow, like really kind of skinny, close together, something like that. Okay, and it also causes it to, we'll say, reflect. Okay, we'll say reflect. Okay, and the reason we say it reflects because it's either going to face down like this, okay? Or it'll kind of, let me draw that a better way. All right, so it'll kind of face down like this, or you'll notice at different times where it's kind of faced up like this. So it just kind of looks like a reflection of itself. All right, so what makes it wider? Just if you notice, look how look how small these numbers are. The smaller the A value, okay, the wider it gets. So we'll say small A value, okay? So smaller A value, the wider it gets. So that means the larger the A value, the narrower it gets. That's true. What makes it reflect though? So like what makes it go from looking like this, okay, where it's like opened up to where it's now kind of open and down like this, the negative. So when A is negative, it's going to make it flip downward. When A is positive, it's going to open up. And let's put that opens up. Negative is going to open down. Okay, so now today we've looked at quadratic equations, but we were able to look at a different form of the quadratic equations, which was written in vertex form. All right, and we were able to see how to determine the vertex just from the form, and we were also seeing like the effects that the A value, the H value, and the K value can have on a quadratic function written in vertex form. All right, so see you guys on tomorrow.